In the realm of science and profound inquiry, the subject of what existed before the colossal impact of the Big Bang has sparked endless debates and captivated thinkers for centuries. This monumental question not only tests our ability to unravel the universe but also challenges the very limits of human knowledge. Imagine standing at the edge of existence, peering into the vast unknown, and pondering what lay there before our universe was conceived. The event of the Big Bang marked the beginning of time, space, and all that we know. Yet, was there a moment before this? Perhaps there was a state of nothingness, a silence before the roaring expansion began. Or maybe something even more enigmatic existed before time itself. As we delve deeper into this mystery, science takes us on a journey beyond the universe's origin into ideas that challenge our understanding. Physicist Brian Cox, known for his contributions to the wonders of the universe, suggests that something extraordinary could have existed before the Big Bang. He urges us to rethink our perception of reality and existence. In this exploration, we will delve into the science, theories, and fascinating secrets that might explain what existed before everything. We'll explore concepts like cosmic inflation, quantum fluctuations, dark energy, and even multiverses. The answers we uncover may astound you but could also provide new insights into our place in the cosmos. To understand what might have existed before the Big Bang, we first need to examine what the Big Bang actually was. According to science, the Big Bang refers to the moment when the universe became incredibly hot and dense, rapidly expanding to create all matter, energy, and fundamental forces. When we look into the night sky, we see evidence of this fiery beginning in the form of galaxies spreading out from a central point. But why did this happen? Was there a time before this dense, hot origin? According to the theory of cosmic inflation, there was indeed a before, and it was far from empty or calm. Cosmic inflation suggests that before the Big Bang, the universe was in a state that was cold, empty, and smooth, a kind of cosmic vacuum. However, this vacuum wasn't entirely empty. It contained an immense amount of energy that fueled the rapid expansion of space itself. This expansion, known as inflation, occurred so quickly that it essentially set the stage for everything to follow. In a fraction of a second, space expanded at astonishing rates until the expansion slowed, and the energy transformed into matter, particles, and the forces we know today. But what was the nature of this energy? Why did it emerge seemingly from nowhere to create the universe? And why did it stop? Scientists believe this rapid expansion created patches of the universe, each undergoing its own Big Bang. Imagine a fabric stretching infinitely with tiny air bubbles forming, each bubble representing a universe, including our own. This idea, called the inflationary multiverse, suggests that there are potentially countless Big Bangs and an infinite number of universes. Our universe is just one of many, challenging our understanding of the very nature of existence and leaving us to wonder, what else is out there? The concept of nothingness before the Big Bang is theoretical, not literal. Even if we removed all energy, particles, and radiation from the universe, it wouldn't truly be empty. Our universe is permeated with dark matter, dark energy, quantum fields, and other forces intricately woven into its fabric. Even in its most stripped-down state, space would still generate new forms of energy. This realization perplexes scientists, as it implies that true nothingness may be impossible. Space itself has properties, rules, and constants that prevent it from being completely empty. For instance, there's a concept called zero-point energy, which represents the lowest energy state of quantum fields. Even in this state, particles can appear and disappear, creating a faint hum of activity even in the emptiest void. This challenges our understanding of a true vacuum and suggests that even before the Big Bang, there was something. One of the most fascinating theories in modern cosmology is the idea of eternal inflation. If inflation could create our universe, it's possible that it continues endlessly. Brian Cox describes a breathtaking inflationary multiverse where universes are constantly being created and expanded. Imagine each Big Bang as a spark igniting another universe, while inflation occurs in different regions, creating countless other universes. This process could theoretically happen forever. This idea of massive universes birthing others leads to an enchanting concept of a fractal universe, where each new universe may, in turn, create its own Big Bang. Each universe exists as a separate, independent space unaffected by the others, given the rapid expansion of space. For scientists, this hypothesis is both exhilarating and unsettling, as it suggests an infinite multiverse with no clear beginning or end. Imagine our universe being just a speck in a vast cosmic framework, perpetually evolving and continuously creating new universes. And what if this is the true nature of reality? There is no before or after, but rather an eternal cycle of universes forming. The way we understand nothingness changes when we consider quantum field theory. According to this theory, the universe isn't a collection of matter floating in space, but a complex network of energy fields filling the cosmos, working together to create everything we observe. These fields are like invisible oceans, with particles acting as waves or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they remain active. Particles can appear and disappear in these fields, briefly borrowing energy before returning it. This phenomenon creates virtual particles, entities that exist momentarily and then vanish, leaving only faint traces of their presence. The idea of virtual particles challenges the notion of true emptiness. Even in an empty universe, where all matter, radiation, and energy are removed, quantum fields would still exist and remain active, sometimes generating transient particles. This constant activity in what should be nothing suggests that the universe doesn't conform to our concept of emptiness. The fields and forces persist, filling the universe with latent energy that prevents absolute nothingness. This understanding raises a fascinating question. If fields create particles and particles create matter, could the universe itself have emerged from this nothingness filled with quantum fields? Dark energy is a mysterious force currently driving the accelerated expansion of our universe. But did dark energy exist before the Big Bang? Some theories propose that dark energy, in a much stronger state, may have powered the inflationary phase, causing rapid expansion. The presence of dark energy today suggests that even if our universe were stripped of all matter and radiation, this force would continue to stretch the fabric of spacetime. This idea leads to a profound question. If dark energy existed before the Big Bang, could it have ultimately created the conditions that led to the birth of our universe? And that the Big Bang was not a singular event but rather part of an infinite sequence of cosmic cycles. In cyclic cosmology, the universe expands, contracts, and is reborn in a perpetual rhythm. During the contraction phase, all matter and energy collapse into an incredibly dense and hot state, resembling the conditions of the Big Bang. From this state, a new expansion begins, creating a fresh universe. This cycle of Big Crunch and Big Bang repeats indefinitely, with no true beginning or end. One version of this theory, known as the ekpyrotic model, suggests that our universe is the result of a collision between two higher-dimensional membranes, within a multidimensional space. When these branes collide, they release an enormous amount of energy, triggering a Big Bang-like event and forming a new universe. The cyclic model challenges the conventional notion of time and origins. It proposes that the universe is eternal, constantly recreating itself in a dance of destruction and renewal. This perspective shifts the question from what came before the Big Bang to what drives the eternal cycles of the universe. Quantum fluctuations and the birth of the universe. Another compelling idea is that the universe emerged from quantum fluctuations in a primordial vacuum. According to quantum mechanics, even in a vacuum state, energy levels are never completely stable. Tiny fluctuations occur spontaneously, creating brief disturbances in the fabric of spacetime. Some scientists propose that one such fluctuation could have been powerful enough to spark the creation of the universe. These fluctuations might explain why the universe appears to have started from an incredibly small, dense, and hot point before expanding into what we observe today. This idea aligns with the notion that nothing is inherently unstable. If even a vacuum state can give rise to quantum disturbances, it suggests that the creation of the universe might have been an inevitable outcome of the fundamental properties of quantum fields. The multiverse and infinite possibilities. The concept of the multiverse expands on these ideas by suggesting that our universe is just one of many. If inflationary theory is correct, the rapid expansion of space could have created countless pocket universes, each with its own unique properties, laws of physics, and initial conditions. In some versions of the multiverse theory, universes could even interact or influence each other in subtle ways. Others suggest that each universe exists independently, with no communication between them. The implications of the multiverse are staggering. It raises questions about our place in the cosmos and whether our universe is ordinary, extraordinary, or just one of infinite variations. Philosophical and theological implications. The exploration of what existed before the Big Bang also delves into profound philosophical and theological realms. If time and space as we know them began with the Big Bang, does it even make sense to ask what came before? Does the notion of before require a redefinition in the context of a timeless state? For some, the mystery of the universe's origins points to a deeper, metaphysical reality. For others, it highlights the limitations of human understanding and the need for humility in the face of the unknown. A journey without end. As science pushes the boundaries of what we know, it becomes clear that the question of what existed before the Big Bang is as much about the journey as the destination. Each discovery opens new doors, leading to deeper questions and more profound mysteries. Whether the answer lies in quantum fluctuations, dark energy, cyclic universes, or the multiverse, the quest to understand our origins will continue to inspire curiosity, wonder, and the drive to explore the infinite. And perhaps, in the search for answers, we will uncover not just the secrets of the cosmos but also new insights into ourselves and our place in the grand tapestry of existence. The huge explosion is certainly not a one-time occasion. It may be part of an undying cycle where universes foster, disintegrate, and then recover in another cycle. This hypothesis suggests that our universe may have been restored from the remnants of a previous universe. The process of compression and expansion in a cyclic pattern implies that there was never a true beginning but rather an eternal series of universes emerging, creating, and renewing themselves over and over again. Cyclic cosmology raises significant questions about the nature of time, suggesting that time itself could repeat rather than move linearly. If this theory is correct, it could mean that what existed before the enormous detonation was simply another form of the universe, one that collapsed only to give birth to our current universe. For scientists, this hypothesis offers a profound answer to the question of extreme beginnings, proposing that there is no clear starting point and that the universe has always existed in some form, transcending our perceptions of time and existence. Gravitational waves provide another intriguing avenue that might shed light on what existed before the huge explosion. These waves, discovered in 2015, are ripples in spacetime caused by incredibly massive objects, such as black holes or colliding neutron stars. They can travel vast distances, carrying information about the events that created them. Could gravitational waves reveal insights about the birth of the universe? A few physicists propose that gravitational waves from before the huge explosion could provide clues about the universe's state before inflation began. These waves might carry traces left by events beyond our standard understanding. Their presence could point to a grander structure beyond the observable universe. These faint signals might unlock information that could transform our perspective, much like the discovery of the Big Bang origin did. What if these signals show remnants of a past universe or an event that occurred before the enormous detonation? As scientists continue to explore the vast reaches of space, the question remains: what existed before the huge explosion? With current theories pointing to quantum mechanics, multiverses, and cosmic inflation, it seems we are closer than ever to unraveling the profound mysteries of the universe's origins. While the complete answer remains elusive, our understanding of what existed before the Big Bang continues to evolve with each new discovery. Exploring these theories could help piece together the bigger picture, the true nature of existence itself. Until then, we are left with a mystery driving science into unknown realms far beyond what we have yet uncovered. As we delve into the question of what existed before the Big Bang, time itself becomes increasingly difficult to grasp. Time, as we understand it, began with the Big Bang, making the concept of before quite complex. If time itself didn't exist before the huge explosion, can we even talk about something existing before it? Some theories suggest that time might not have a clear starting point, and our understanding of it may be limited by the current framework of physics. One fascinating aspect of these theories is the possibility of new laws of physics, ones that are yet undiscovered or even unimaginable within our current understanding. If the universe as we know it began with a Big Bang and before that, there was a state of nothingness or cosmic inflation, what governed the forces and particles in that pre-Big Bang state? Could there be a fundamental layer of reality that transcends space and time, where the usual laws of physics completely break down? This metaphysical layer would defy everything we understand about the universe, yet it could hold the answers to some of the most profound questions. Some experts speculate that the universe's beginning might not have been a single event, but rather the result of interactions between higher dimensional forces. According to string theory, for example, the fundamental building blocks of matter are not point-like particles but one-dimensional strings vibrating at different frequencies. These strings could exist in higher dimensional spaces beyond the three-dimensional space we observe. If this theory holds any truth, our universe could be just one slice of a higher dimensional space that interacts with others, forming a multiverse. In this scenario, the Big Bang could represent the intersection of these dimensions, with a continuous cycle of universes being created and destroyed in higher dimensions. Furthermore, theories like the ekpyrotic model suggest that our universe might have resulted from a collision between two higher dimensional branes, membranes of spacetime that exist in multiple dimensions. These collisions, if they occurred, might have triggered a Big Bang-like event, initiating a new cycle of expansion and contraction. Such models provide a framework for understanding the universe's origins that doesn't rely on a traditional singular beginning. Instead, they present a scenario of constant rebirth through cosmic events. This idea challenges our conventional thinking about the universe's beginning and opens up possibilities for how it might evolve in the future. There are also fascinating connections between these cosmological theories and philosophical questions about the nature of existence. If time, space, and matter have always existed in some form, does this imply an eternal and continuous reality beyond our perception? Or are we part of an endless cycle of creation, expansion, and destruction? Some suggest that the answers to these questions may lie outside the realm of science altogether and may only be fully understood through spiritual or philosophical inquiry. This implies that the limits of human understanding are not just about advancements in physics but also about the profound, existential nature of reality itself. In conclusion, while we may never fully answer the question of what existed before the Big Bang, the theories and concepts surrounding it offer a rich tapestry of possibilities. As our understanding of quantum mechanics, dark energy, and cosmology continues to evolve, we may inch closer to uncovering the true nature of existence, time, and the universe itself. Whether the answer is grounded in science, philosophy, or something entirely beyond our comprehension, the mystery of what came before the Big Bang continues to captivate and inspire humanity's quest for knowledge.